Kia ora and welcome to this video about how to find the equation from a graph of a parabola when we're given the x-intercepts. So this is made especially for Sam, and I'm going to do a whole lot of examples from Mr. Black's awesome graphs textbook chapter. So all of the examples we're going to do here look like this. You're going to get a parabola graph and you have to write the equation. And notice that in every single one of these graphs, we're going to be given the x-intercepts, right? So we're given a couple of points where the y value is equal to 0. In most of these examples, there won't be a scale factor, but I'm going to teach you how to do it even if you didn't realize that that the scale factor was just 1. Lastly, if you're watching this and you're not in my class this year, this comes at the end of our graphing topic, so we've done quite a lot of work on these ideas already, so it might be a little bit too fast for you. Okay, so if you are in 11 MAT this year with me, can you grab your book and get ready to try and write down the equations as we go? So let's look at the first couple really slowly and see what's going on. Well, we know that we've got a parabola, and there are 3 ways to write the equation of a parabola. There's expanded form, y equals ax squared plus bx plus c, and there's factorized form, which is the one we're going to spend most time on here. Now, it doesn't really matter what you call the letters here. I might call them M and N, okay? And these 2 bits here are going to be the focus of this video. And then the last form is vertex form, which we've done lots of as well. And that's where we're given it as a something squared plus a number on the end, okay? And we've looked a lot in class at that last one. So this video is not going to talk about that one at all. But they're all different ways to write the same thing, right? So sometimes we can use kind of combinations of the 2. One thing that you're going to notice in this video is that in Mr. Black's graphs, he's often given us the y-intercept. And that's useful because that means that we can see what the plus c would be when we're in expanded form. But mostly we're going to start by concentrating on what these 2 x-intercepts can tell us. So in this first one, we can see that we've got x equals 1 and x equals 3 are places where y equals 0. Now, if I rewrite that, I can write that as x minus 1 equals 0 or x minus 3 equals 0. And if you get really stuck, if you come back to this, this is going to be a good way to help you write the equation. So what we can say now is that y is equal to x minus 1 times x minus 3. And I'm going to put this k in here for the scale factor. So what's going on here is that we know that when x is 1, then we would get 1 take away 1, giving me 0 here. I'm just going to write that out a little bit more slowly. Let me just try and move the screen down. Okay, so if x equals 1, we would get y is equal to k times 1 take away 1 times 1 take away 3. This is going to give me 0, right? And if x equals 3, then this equation will give me the y value being k times 3 minus 1 times 3 minus 3, right? And this will give me 0. So that's how it works, and that's after we've built up our understanding from doing lots of work with tables of values. Okay. Sam, I suspect this is probably a little bit too slow for you, but never mind, just hang in there. All right, so step 1 is to figure out what are my x-intercepts. Step 2 is to put them into factor form. And step 3 is to look at the scale factor. So we're not quite finished with this one yet. We know that it's a parabola, and we know that it's going through these 2 points here. But there are an infinite number of parabolas that could go through those 2 points. For example, I could have a parabola that is much narrower, that goes like that, or I could have one that goes like this. Terrible graphs, but you get the idea, right? And that's what the k, the scale factor, is all about. Is it saying, have I got my most basic kind of parabola, which is the x squared kind? And remember that we check for that by looking at whether we've got a pattern where we start at the vertex, we go out 1 and up 1, and then out 1 and up 3, and then out 1 and up 5. So you can see just from the stylus on that graph that this is the most basic one. It's an x squared one. But I'm going to show you how to check that with algebra as well. So whenever we write the equation in vertex form, we're going to write it assuming that we haven't got the easiest case. So we're always going to write it like this. We'll put down our two factors, and then we'll say, well, maybe we've got a scale factor. And now we're going to use another point on that curve to say what's the scale factor, right? So the idea is if we know that this point here is on the curve, that means that there's only one parabola that goes through these 2 points that will make it work. So this point here is 0 and 3. So we did this in class when we were working with vertex form, but we can do this for any parabola equation. We can say if y is 3 and x is 0, what must that scale factor be? So we get 3 is equal to k times -1 times -3. So 3 is equal to 3k. That gives me k equals 1. Now that really shouldn't come as a surprise because we just went through how this fits my most basic pattern of out 1, up 1, out 1, up 3. So we don't need to do all that algebraic work there, but it's good to be able to for when we get to more complicated ones. Right, so that was a really slow going through of what we're going to do. I'm going to do a couple more quite slowly, and then I'm going to pause the video and get you to try some. So in this next one here, we can see that our x-intercepts are here and here. So this one, if we have x equals -2, then that's the same as x plus 2 equals 0. So that's my first factor. And my second one will be x minus 2. Again, just from looking, I can see that the scale factor here is going to be 1. So I go to the vertex, I go out 1, up 1, out 1, up 3. So there are no, there's no stretching or squeezing going on here. So I'm going to do that one without doing all the algebra first. Right, so we know that that's how we would write that equation. Now I'm going to do it showing you how we can do it using substitution. So we know that 0, -4 is on the curve. We can substitute those values in. -4 is equal to k times 0 plus 2 times 0 minus 2. So just one more time, in case you're just getting this, we know that that 0 value is this x value. So we're substituting in 0 wherever we've got x in there. Okay, and we know that the y value is -4, so we're substituting in -4 here. Then we're going to do some year 9 algebra. So we've got k times 2 times -2, which gives me -4 is equal to -4k. So k is equal to 1. Right, so I'm teaching that so slowly at this stage because when you come to do graphing in year 12, the skill of substituting in a point to check the scale factor is a really, really useful one. So it's good to start understanding it now. Okay, let's go on to the next two. Pause the video and try and write those two down. All right, so in this one here, we've got x equals 0 or x equals 2. So this is x minus 2 equals 0. In this one here, we can write just like this. So y is equal to k times x minus 2. You can think of x equals 0 in a weird way as x take away 0. But we don't need to write that, right? So we can just write x. So we get this, but we can see again quickly, if we go to the vertex and we go out 1, up 1, out 1, up 3, our scale factor here is just 1. So my equation is y equals x times x minus 2. For this next one, hopefully you figured out that it was y equals k times x plus 2 x plus 1. And again, k is equal to 1. There's no scale factor. But it's a little bit harder to see that here because the vertex is sitting here, and that's not at a very nice value, right? It's halfway between here, so it's kind of hard to do the out one, up one thing. So this is one where it is worth doing it using the point, and the point is 0, 2. So we could do this. We could go 2 is equal to k times 0 plus 2, 0 plus 1. 2 is equal to k times 2 times 1. So k is equal to 1. Or the other way we could do it is we could look at what we get when we expand this out. And for easier ones, this is a nice way to do it. So we know that my function will be k times x squared plus 3x plus 2. Now we're given the y-intercept, which is at 2. And we can see we've got exactly the right y-intercept in here if k is equal to 1. So that's another way to quickly work out if we don't have a scale factor that's different from 1. Right, here are questions 5 and 6. Pause the video and write them down. So this time we've got y is equal to something x plus 1 times x plus 4, and we'll put in a k. Oh, I don't know where that just went. It disappeared. Never mind, try again. Make it a better colour. Y is equal to k times x plus 4, x plus 1. You can see that my y-intercept of 4 is matching up to what I just had. I think I'm going to stop using that fancy new pen and we'll just write the answer down. So x plus 1 times x plus 4. Okay, and notice that these two are working with my y-intercept. In this one here, we've got y is equal to k times x plus 1, x minus 1, sorry. K times x minus 1, x minus 3. Let's look again at the y-intercept. It's very useful when we've got it. We can see that it's matching up to -1 times -3. So again, if you're starting to get the hang of how the methods all link up, we've got x squared minus 4x plus 3. That plus 3 matches this, so k must be 1. And it's fine to write that either in factorized form or in expanded form. Okay, a couple of minutes to do the next ones. Here's number 7 and 8. Y is equal to k times x plus 4, x plus 2. And you can see that that y-intercept is at 8, and also that it's symmetric with this one here. So k is equal to 1, and y is equal to x plus 4 times x plus 2. Let's look at this one. We've got a -4 here, so x plus 4 equals 0. And we've got x is equal to +2, so x minus 2 equals 0. So y is equal to k times x plus 4 times x minus 2. The y-intercept of -8 is matching up to these, so k is going to equal 1. Again, if you're not confident doing it that way that I've just done with the y-intercept, go back to the slower way of substituting everything in. Okay, question 9 and question 10. We've got these two intercepts, so it will be y equals k x plus 6. And I'm going to use a point in this one here. So we've got -4, -7 on the curve. -7 is equal to k times -4 times -4 plus 6. Is that right? You know that point is wrong, isn't it? It's not -7, it's -8. That's better. We're going to get some bad numbers. So -8 is equal to k times -4 times 2. -8 is equal to -8k. K is equal to 1 again. All right, and there's one last one for you guys to try, which will be this.